Hello everyone. So in the last video we have had some introduction about how if condition, what if condition is, if statement or if condition will work, and what it will actually do, and what is the structure of it, and the functionality of the if condition as well. So in today's video we will see how we can write a code with the if condition. We will write a simple code and see whether it works or not. I'm sorry guys. Okay. So let's do a small thing. Okay, let's write a code, okay, to do something like this. Okay, let's write a code using an if condition where a particular condition is true, we switch on an LED. Okay, otherwise we are not going to switch on the LED. Okay, right, fine. So I will write an if condition. So if the if condition is running continuously, if the if condition is always active, where we should write it? Inside the void loop, right? Normally we are writing things inside the void loop. Only the setup things should be inside the void setup. If I write the if condition inside the void setup, what will happen? The if condition evaluation will happen only one time. After that, whatever happens, okay, whether you pass the exam or not, whether you are doing something or something, or some input is coming or not, if condition will not be running. Okay, so there's no point. For example, let's say I am getting a sensor input. Okay, let's say I am getting analog input. Okay, and if the input is more than a particular value, I want to switch on an LED. If it is less than, forget about the rest. Otherwise, I don't switch on that, right? So if that write that if logic with the if condition inside the void setup, what will happen? Only one time it will run. After that, whether you are rotating the analog pin or not, no change you will see. Only if you write inside the void loop only, if condition will run repetitively, so that when you are increasing the analog input, LED will be on. Then when you are decreasing the analog input, you will see LED goes off, because if condition is continuously active inside the void loop, because void loop is repetitive. Okay, so you understand why we should write it inside the void loop, right? Okay, all good. So what I'm going to do is, I'm not going to do any analog business. What I will do is, I will do a very simple thing. Okay, first what I will do is, I will take a variable and I will manually assign a value to the variable. Okay, and then I will evaluate the value inside the if condition. Okay, if that value is true, I will switch on an LED, otherwise I will switch off an LED. Okay, let's see how we can do it. Okay, right. Okay, so first what I will do is, I will assign the value 6 to an integer value, integer x. Okay, so in a memory location 6 will be stored, and x will be used as the reference to that value. Okay, so since I am going to use an LED, let's connect an LED to the pin number 7. So let's have a pin mode here. Okay, what we should write 7 output. Okay, now let's have a if condition, right? So as I said you here, I'm going to copy and paste it. Okay, I don't know whether it will be in the proper format. Let's see. It looks like messy. Okay, no problem. Okay, so you can see if condition is there here, if statement is, and the curly braces that are owned by the if condition, because we always know these curly braces are the limiting boundaries. Because see, if you are wondering about the void loop block, the ownership of the void loop block exists between these open and close curly brackets. This is the area of the void loop. Likewise, what is the area of the if condition? The open and curly brackets of that particular if condition. Okay, that is owned by him. If you write a code before that or after that, that will never be affected by the if condition. You understand what I'm telling? Okay, fine. So I will write a condition. I will check whether this value is greater than 5 or not. Okay, so what I will do is, I will write if. Okay, just notice this guy. So this is where I'm going to write the condition, right, in this place. Okay, so I'm going to write if x, okay, x is greater than 5. So notice this, guys, this is called if I am correct, comparative operator. I am not sure. So this is being used to compare, okay, whether this is the greater than sign. If you know mathematics, you know this, right? This is a greater than sign. So I am saying x is greater than 5. I am not saying anything. I am saying x is greater than 5. Since this x is greater than 5 is in a place where a condition should be, okay, then therefore that means, since this x is greater than 5 in a place where the condition is supposed to be, this if will consider is as a condition that has to be evaluated. Okay, so every time the if will evaluate this condition and see whether this is true or false. Okay, that's all if is supposed to do. And if knows, if condition knows, if this is become true, I'm going to let the program go through myself. Okay, or I'm going to let the code or let the program code run through these lines. Okay, let the coding to run through this line. Otherwise, okay, if it is false by any moment, I'm not going to let the code go through this. Okay, I will simply skip everything. The program will simply skip everything within these two curly braces within the area of the if, and the program will immediately skip everything and go to the next line. Okay, so if you are written something in the next line, that will be implemented as usual. Okay, you understand what I'm telling? Only if this is true, we will do this. If this is false, what we will do? We will never get into that. We will skip everything and we will go to the next line. Understood? Very clear, right? Okay, that's fine. So I will remove this for the moment. So what is our command? We are going to switch on the LED, right? So I will say digital write. Okay guys, 7 5 or one time switch on LED, nothing else I am doing. Okay, so you are seeing if it is greater than this, it will happen. If x is not greater than 5, this will not happen, and program will come to the next line. There is nothing in the next line, so program will come here, and it will again come and check still this is true or false. If this is true, it will do this again and come to the next line, and again will come and check. By some means, if it becomes false, these things will be skipped and program will come here, and again it will come and check. Okay, you understand that? Okay, so for our logic, x value is 6. Okay, so when we are comparing x is greater than 5, we know this is a true scenario because x is 6. So that means 6 is greater than 5. So when we are calling x, we are referring the value in the memory location, right? So 6 will be considered here. So it's greater than 5. And simply saying x is greater than 5 is true. Okay, it is always true because we never change it. So the program will come here and switch on the LED. Okay, and it will come here, it will come here, it will come here, it will come here, and again it will come here. Okay, and still x is 6. We never change x value. So still it is true. Program will come here and again implement it. Since the LED is first time switched on and it was never switched off after that, the on will be still there, no matter whether you are running it or not. Even because it was switched on already, right? So it will remain switch on. Though you are repeating, it will be switching on, because unless we are explicitly saying it to switch off, it will not go switch off. Okay guys, so you understood that, right? It's very simple. Okay, so x value is 6, so that this LED should be on, right, according to us. So I'll copy the code and I will use the Tinkercad, okay, to immediately check this scenario whether it work or not. I mean, in this situation you should use your real Arduinos. Okay, I want you to do your real Arduinos with an LED, no Tinkercads. Okay, no simulation platforms. Once you are done, then you can go to the Tinkercad or anything and you can simulate and do. But for the moment, go for the real thing. Okay, so that you can have some experience. So before that, I will just verify and make sure this code is error free. I mean, I will compile this, and I am expecting the LED to be on, right, because x value is 6. Oh my god, why is it taking this much of time? So if it is taking too much time, I will hold the video, guys, because I am allowed to use only 10 minutes of time to record. It's already 9 minutes and 15 seconds. So if it is not working, taking too much time, I will continue the demonstration in the upcoming video, right? Okay, it looks like it's taking time, and it is already 9 minutes and 30 seconds. Okay, so I think it's better once it's completed, we can do the demonstration in the upcoming video, next video, I mean. Okay, I hope it will get compiled. It's compiled, right guys? So the demo we will see in the next video, guys. Hold on and follow me in the next video.